Welcome back, class. Tonight we're going to learn about temperature and heat. We're moving into our third of the 5 California state standards in physics, and this standard is heat and thermodynamics. We really need to understand what temperature is and what it means about a substance so that we can begin to apply these laws of thermodynamics to understand how a gasoline engine or a steam engine or a diesel engine or even a refrigerator works. So, let's move right in. So temperature is the measure of the average molecular kinetic energy of a substance. And so you have to visualize this and picture this in your mind. The molecules of substances are actually not stationary. They actually vibrate around, they rotate around, and they even translate. They move from one location to another if it's a liquid or a gas. So these molecules are not stationary. And so as these molecules vibrate more, translate more, and rotate more, as they increase their vibrations, translations, and rotations, the temperature also increases. And we're going to talk more about that in just a little bit. And as you know, there are 3 scales for temperature. We use the Fahrenheit scale, which measures in degrees Fahrenheit. The rest of the world uses the Celsius scale, measured in degrees Celsius. And then there's also a scientific scale called the Kelvin scale, which, notice, there are no degrees in the Kelvin scale. So what I was going to do is draw for you a little bit about these translations, vibrations, and rotations, just so that you understood exactly what we're talking about. So here's a molecule. This molecule can move back and forth. This would be a vibration. This molecule could also rotate back and forth. This would be a rotation. And then the molecule could actually move from one location all the way over here to another location. And that would be a translation. And so those are the 3 types of kinetic energy that a molecule can have. So let's look at these temperature scales a little bit more. And there are 3 temperatures we really want to understand well. Three points that we can discuss as it relates to water, for example. And water is something that is all over the surface of the Earth, and so we can use it to calibrate a temperature scale anywhere on Earth. And that's what they did back in the 1800s when these temperature scales were first being developed. So these are 3 points, and this point up here is going to be the boiling point of water. Okay? This point here is going to be the melting point, or also known as the freezing point. It's the same point of water. And down here is the lowest temperature we could possibly get to, when the molecules actually cease to move at all. They actually stop vibrating, rotating, and translating. And we call that point absolute zero. So we have absolute zero, which is the point at which the molecules have zero kinetic energy. They do not move at all. We have the melting point of water and the boiling point of water. So do you know the temperatures for the melting point and the boiling point of water on the Fahrenheit and the Celsius scale? If you do, why don't you go ahead and pause this video and write those in. Of course, the melting point of water, or the freezing point of water in Fahrenheit, is 32 degrees, and the boiling point is 212 degrees. Now this is at standard temperature and pressure. So this is, at standard pressure, which is at sea level. If you actually move up in elevation, the boiling point actually decreases, and so you might notice that it takes longer to cook food, to boil food, say when you're at Mammoth, when you're at higher elevation. Now the boiling point of water in Celsius is 100 degrees, and the melting point is 0 degrees. And this makes the Celsius scale particularly convenient because there are only 100 degrees difference between the boiling point and melting point of water in the Celsius scale, while there are 180 degrees on the Fahrenheit scale. And as it turns out, the Kelvin scale, which is our scientific scale, there are only 100 Kelvin difference as well between the boiling and melting points. And so that means that the Kelvin and Celsius scales have the exact same scale. 1 degree change in Celsius is the same as 1 Kelvin change in temperature. So now let's go down here and look at absolute zero. Absolute zero is the temperature at which the molecules don't move at all. You cannot get colder than absolute zero. And in Fahrenheit, that temperature is negative 460 degrees. in Celsius, it's negative 273 degrees. And in Kelvin, it's 0. So now you see why we have a Kelvin scale. There are no negative temperatures in Kelvin. That'll be important when we talk about a concept in just a minute. So since these have the same scales, Kelvin and Celsius, if there are 273 degrees of difference between absolute zero and the melting point on Celsius, it's the same in Kelvin. So that would make the melting point of ice in Kelvin 273 and the boiling 373. Notice these scales are exactly the same. All right, so temperature tells us about the average molecular kinetic energy of a substance. But sometimes we want to discuss the total molecular kinetic energy of the substance, and we call that internal energy. Internal energy is also known as thermal energy. Sometimes we call that heat, but it's different. And it's the measure of all of the molecular kinetic energy of the atoms of a substance. So if you take each of those molecules' energies and you add them all together, that is the internal energy. And what do we measure energy in? That's right, we measure energy in joules. Okay? Now the symbol for internal energy is a U, capital U. All right, so now we get to heat. This is the important thing to understand. Heat is a flow of temperature. So how do we change the temperature of a substance? Well, we put it in contact with something that's colder or hotter. And remember, if a substance is colder, that means its molecules have less energy. And if a substance is hotter, it means its molecules have more energy. So heat is when two substances who have different temperatures come into contact and energy flows from the hotter substance, where the molecules have more energy, to the colder substance, where the molecules have less energy. And it actually does that through elastic collisions. The molecules actually bump into each other and transfer energy, kinetic energy of the molecules, through those elastic collisions. And the units of heat are the same as the units of internal energy, joules. And you've probably heard us in the United States use the unit calorie for energy, or even for heating homes, BTUs, which are called British thermal units. But we're pretty much only going to use joules. Now, here is a big warning. Okay? Substances do not contain heat. They contain thermal energy. Heat is the flow of energy from hot to cold. So one substance can't have heat, because heat is energy that's in transit. It's energy in motion from a hot place to a cold place. All right? It's not something that you can have. You can't have heat. You can have thermal energy, but you can't actually have heat. Okay? So if you can come to class tomorrow with an understanding of these concepts, we're going to look at this and we're going to apply it by looking at this, which is gas molecules moving around in a closed container. And you can see when we add heat here, I'm going to go ahead and add heat in the form of fire. You can see the temperature is increasing here. And we're going to look at this more tomorrow. And if we put it in contact with something colder, okay, which means the molecules are going to slow down. Energy is being taken away from the gas molecules and being given to the colder substance. In this case, it's ice. So this is heat and temperature. We're going to look at this more later this week. Thanks, and have a great evening.